So you want to build your own personal AI computer? We're going to do exactly that today. But first, I'm going to let you in on the single biggest secret that almost everyone gets totally wrong. Let's get into it. Okay, so you're building a machine to run these powerful AI models right there on your desk. What's the one number, the one spec on that sheet that you should absolutely obsess over? What's the real thing holding you back? I can pretty much guarantee it's not the one you're thinking of. You know, all that common wisdom we've learned from years of building gaming PCs. Well, for AI, it's a trap. And that right there brings us to the number one mistake people make when building an AI rig. They spec it out just like a top-of-the-line gaming computer. You know, max out the processing power, get the fastest graphics card. And that is precisely why their setup just doesn't work the way they expect it to. They put all their focus, all their budget, on the GPU's core speed. It's raw number crunching power. But when you're running these huge language models, that's just looking at the wrong number entirely. To really understand what's going on, we need to think about this differently. So let's forget the tech specs for a second, and just imagine your computer is a high-end restaurant kitchen. Okay, so in this kitchen, your GPU, your graphics card, that's the chef. It's the master doing all the hard work, all the heavy math. And its core speed? Well, that's just how fast the chef's hands move. You know, how quickly they can chop, mix, and get the food on the plate. But here it is, the most critical piece of the puzzle, the VRAM. That's the video memory on the graphics card. And that is your kitchen counter space. It's the actual surface where the chef lays out every single ingredient to work on the recipe. And the AI model itself? Well, that's the recipe. So when you hear about a 7B model, that just means 7 billion parameters. Think of it like a massive, complex recipe with 7 billion tiny instructions. A bigger model is usually a smarter model, but it's also a much, much bigger recipe that needs a lot more counter space. And what about your computer's regular system RAM? That's the big storage room in the back. Sure, it can hold a ton of stuff, but it's way, way slower for the chef to get to. If the recipe is too big to fit on the counter, the chef has to waste all their time running back and forth to the storage room, and the whole kitchen just grinds to a halt. So here's the absolute key takeaway. The size of your counter, your VRAM, matters way more than how fast the chef's hands are moving. If the whole recipe doesn't fit on the counter, it doesn't matter if you have the fastest chef in the world. Your AI's performance will tank, going from maybe 40 words a second down to 2 or 3. And at that point, it's basically useless. So how much counter space do you actually need? Well, here's a quick cheat sheet. For the standard compressed models people use, a 7 billion parameter recipe needs about 5 gigs of VRAM. A 14 billion model needs 10. You can see how this starts to add up really fast. And remember, that's just to hold the recipe. As you're talking to the AI, you're adding more dishes to the counter, which takes up even more space. Okay, that's enough theory. Let's make this real. Let's turn this into an actual shopping list. I'm going to walk you through 3 different tiers of power so you know exactly what to look for. First up, Tier 1. This is the perfect way to get started, and it's probably cheaper than you think. The heart and soul of this build, the one thing you can't compromise on, is the NVIDIA RTX 4060 Ti with 16 gigabytes of VRAM. Please, do not get the 8 gigabyte version. That's the trap we talked about. Pair that up with a solid Ryzen 5 CPU, 64 gigs of system RAM, and a 2 terabyte solid-state drive. For around $1,200 to $1,500, this machine will run those 7 and 14 billion parameter models like a champ. Now, if you're an Apple person, the equivalent here would be a MacBook Pro or a Mac Mini with 16 gigs of unified memory. See, on a Mac, the RAM and the VRAM are all one thing. There's no separate storage room and counter, it's just one huge, incredibly efficient workspace, which makes things really simple. All right, Tier 2, this is the sweet spot for any serious power user, and you have a really interesting choice to make here. You can go for the faster chef with a brand new RTX 4070 Ti Super, which has 16 gigs of VRAM, or you could do what a lot of the pros do. You can get a bigger counter. This means buying a used RTX 3090. It's an older card, yeah, but it comes with a massive 24 gigabytes of VRAM. So what does that giant 24 gig counter get you? Well, now you're running 32 billion parameter models without breaking a sweat. These are models that really start to compete with the big cloud services for things like coding and complex tasks. This is the tier where serious AI workflows become possible. And for Mac users, you're looking at something like a Mac Mini M4 Pro with 64 gigs of unified memory to play in this league. And finally, we have Tier 3, the Pro build. Now let's be honest, this is overkill for most people. But if your work truly demands the most local power you can get, this is it.
We're talking about the RTX 4090 with 24 gigs of blazing fast VRAM, a top-end Ryzen 9 CPU, and 128 gigs of system RAM. This machine runs those 32B models effortlessly and even lets you start playing around with the huge 70B models.
So getting the hardware is really only half the story. To make it all sing, you need the right software and, a little bit of inside info about how these AI models are packaged. When you're just getting started with software, there are two fantastic free tools that pretty much everyone uses, Llama and LM Studio. If you're cool with using a command line, Llama is super simple and crazy efficient. If you'd rather have a nice, clean visual interface that looks like a chat window, LM Studio is perfect. Honestly, you can't go wrong with either one, and they both work on Mac, Windows, and Linux. And here's a pro tip that's going to save you a lot of headaches. These models come in different formats, kind of like how movies used to come on DVD or Blu-ray. The format called GGUF is the universal one. It works great on everything, especially Macs. But if you have an NVIDIA card, keep an eye out for models in the AWQ format. It's been specially optimized for your hardware and can give you a really nice speed boost. Okay, let's zoom out. You've built this incredible machine. But how does it really stack up against the giant models in the cloud, like GPT-4 or Claude? It's important to set the right expectations here. The best way I've found to think about this is local AI is your home gym, and cloud AI is that huge commercial gym downtown. Your home gym, it's 100% private, it's always open, and once you've paid for the equipment, every workout is free. It can handle 80% of everything you need to do, but for that one super specialized heavy lifting machine, you still go to the commercial gym. Really, the smartest way to work is to use a hybrid of both. So if you only take one single thing away from all of this, please let it be this. Buy the counter space, the VRAM, not just the chef's hand speed. That one decision will determine pretty much everything about your experience with local AI. So there you have it. You know the secret now. You know the one number that matters more than anything else. And you've got a blueprint for 3 different levels of power. So the only question left is, what are you going to build?